Okay, this is the special right triangle, the 45, 45, 90 special right triangle. So before we start, let's go over the simplifying that we've done in class already. Um, okay, so here we have a 6 square root 2 times the square root of 2. We want to multiply the two square roots together. Alright, and we get a 6 times the square root of 4. Alright, and we simplify the radical, which is square root of 4 is 2, so that's times 2, 6 times 2. And multiply the 6 and the 2, and we get 12. Alright, now with the square root on bottom, we must multiply by its conjugate, which is square root of 3 times the square root of 3. What you multiply to the denominator, you must multiply to the numerator. Alright, so this gets us 6 square root 3, and square root of 3 times the square root of 3 is just 3. Alright, now we have a fraction, 6 over 3, where 3 goes into 3 and 6 evenly. So we can further reduce it. 3 goes into 3 once, 3 goes into 6 twice, square root of 3, and anything over 1 is itself 2 square root of 3, and that's our final answer. Alright, number 3, same process. Multiply by square root of 2 in the denominator, multiply by square root of 2 in the numerator. Alright, so we get 5 square root of 2 over square root of 2 times square root of 2 is just plain 2. And since 5 halves doesn't reduce, we can leave it as the fraction 5 square root of 2 over 2. Alright, so try to avoid decimals unless the problem asks you to do so. Alright, so here's our theorem of the 45, 45, 90 triangle. It's basically two side lengths, and the hypotenuse is the measurement of the leg times the square root of 2, as you can see there. Now, let's talk about this just a little bit. Let's take a square. Alright, we'll call that a square. We know all the sides in the square are congruent, which means if we have a side length x here, this is the same size, top same size, left side the same size. Take a diagonal. Alright, we need to know how long that diagonal is. We know that we have right angles in a square. So to figure out what this diagonal is, we know that this is our hypotenuse opposite of the 90-degree angle. So our legs, we can label them as A or B, however we see fit. Alright, and we'll use our Pythagorean theorem here to figure out the side length of C. Alright, so substitute. A squared is A is equal to x, so we have x squared. B is equal to x, so we have x squared again. And then C is just C squared. Alright, we can combine the two like terms, the two x squareds, and we get 2x squared and equals C squared. Alright, the C is somewhat isolated, but we need to get rid of the power of 2. And to do that, we'll take our square root of 2. Do it to one side, got to do it to the other. And we get C out of that. Square root of C squared is C. Alright, now here, remember, we can split off the radical by doing a square root of 2 times a square root of x squared. Alright, so square root of 2 is just the square root of 2, and the square root of x squared is x, like so. Now we don't write it this way. Conventions has us put the whole numbers and variables in front of the radical, and that's how we write numbers with radicals. So that's x times the square root of 2. So our C, our hypotenuse, equals x times the square root of 2, which is how we get our rule here. And we'll use this as a template for solving triangles that have the angle measures of 45, 45, 90 degrees. And they'll always have these patterns where the legs are the same measure and the hypotenuse is times a square root 2. bigger than the leg. Alright, so example 1. Find the length of the hypotenuse. This is our hypotenuse. Alright, so 90, 45. This must be 45 degrees. This is the leg, 8. We know this side is 8. And using our right triangle, special right triangle rules, we know that the hypotenuse is square root 2 times bigger. So if this is our x, and we know our hypotenuse is x squared root 2, and we know 8 equals x, we simply just substitute the 8 into x and then multiply by square root 2, and that is your answer there for your hypotenuse. All right. B, same thing. Remember, 3 square root 2 is a number, so they're both the same distance. Same rule. This whole thing is your x. So the rule again for the hypotenuse is x square root 2. So we take the x square root 2 for our hypotenuse, and this whole number goes into the x there, just like the 8 from example A. So we get 3 square root of 2 times the square root of 2. Okay. Now again, it's not simplified, just like from above. We must multiply the 2 square root 2's, and this gets us 3 times 2, which gives us a 6 as our hypotenuse length. Again, this rule here, you can find right there. Alright, extra example 1, 45. Okay, this is a leg and this is 12. This is a leg of 12. We are still using our rule. I'll write it here if you need to see it. Right angle, 45, 45, x, x, x square root 2. Alright, so we're always keeping that in mind. So if our x is 12, then our hypotenuse is 12 square root of 2. B is very similar. Again, when we have two side lengths that are the same measure, the angles opposite are also the same measure. And since this is 90, they must be divided by 2, which is left over, makes them 45. This was from a previous lesson. Okay, so we have, again, the rule for hypotenuse is x times the square root of 2. Our x is 10 square root 2, so we will substitute that in as 10 square root 2 times another square root 2 from the special right triangle rule. This equals 10 times 2, which gets us 20 units. Box that one in there. Alright, so these are designed so that we can solve them pretty fast. Alright, let's go on to example 2. We're going to go from given the hypotenuse, we're going to find the legs. Now remember, again, draw the special right here, just so we have it in mind. 45, 45. Alright, so we have x, hypotenuse x squared 2. Okay, we're always thinking that. Okay, so here we have a hypotenuse length of 5 square root 2. Now remember, this front number is your x, because the hypotenuse is square root 2 times longer than the side length. So in this case, x is 5, which makes this a simple solve because that's 5. It's just a number in front of the square root of 2. Alright, so now it's asking what is the area of this triangle, which is the base times the height. So we have A equals base times your height over 2, or 1/2 base times height, whichever one you'd like to use. Alright, so the base on this could be either leg. Alright, if you want to redraw it, this is kind of what, probably easier to think of. 5, 90 degree, 5, 5, square root of 2. Alright, so we have a height of 5 and a base of 5. So basically our area is going to be 5 times 5 over 2, which gets us 25 over 2, and that gets us whatever half of 25 square root 2 is. Excuse me, of 2, 12.5. Couldn't think there for a second. Alright, units. We are doing a measurement, so let's go ahead and put units squared. Remember, area is always squared. There we go. Alright, so there's the formula for that there. Example 2, same thing, we still keep that triangle in mind. So we have a hypotenuse of 15 square root 2. So again, the front number is your x. Alright, so this means this is 15 and that is 15. Alright, so we found that. Area is 1/2 times the height of 15 times another height of 15 gets us 1/2 of 225. And what does that get us there? $112.5 units squared. Alright, so simple area back from 7th and 8th grade. And then finding the height and the base by using our special right triangle. Alright. Alright, so simple multiple choice problem. Obviously this is 45. Always check to see if it's 45, 45, 90, 36, 36. Real simple solve. 36 square root 2, because the hypotenuse is always square root 2 times longer than the leg, and that will be A right there. So once you get really good at this, you can solve these extremely fast. Alright. Find the length of WX. Alright, good. We did that. Be sure to read the question too. Alright, so triangle MNP is a right triangle. Find the length of the line segment MP. Alright, so again, find the hypotenuse. Okay, 90, 45. This has to be 45. So it's 18 inches. So let's find that hypotenuse, which would be 18 square root of 2 inches. And that would be our answer for D. Okay, pretty quick. Alright. Guided practice. Alright, so find the value of the variable. Alright, so more practice. Again, there's our hypotenuse. The number in front of the square root 2 is our x. So x is 2. This is 2. Alright, variable. Okay, got our legs again. Our hypotenuse is y. Okay, so this means y is going to equal the square root of 2, which is our x, times the square root of 2, which gets us 2 as our length. And that is it. Alright, again, here is your triangle if you must remember the rule. Okay, we're always thinking that. Eventually you don't have to draw it anymore. Alright, so we have here a square, just like we derived earlier. So again, just any part of this, any half of this you could use here. So we have side length of 8, which means D is equal to 8 times the square root of 2, and you are done.